Fresh observations of the mysterious interstellar visitor 3I-ATLAS are revealing properties that, well, challenge everything scientists thought they knew about this cosmic wanderer. What initially appeared to be a straightforward comet from another star system is now displaying characteristics that have some researchers questioning whether we're dealing with something far more extraordinary. The object's bizarre orbital path, suspicious timing, and anomalous behavior patterns are sparking intense debates in the astronomical community. Could this visitor be more than just another space rock drifting between the stars? Fresh observations reveal mysteries. The latest observational data from 3I-ATLAS has sent shockwaves through the international astronomical community, revealing properties that really defy conventional understanding of interstellar objects. Advanced spectroscopic analysis conducted by Dr. Alan Fitzsimmons at Queen's University Belfast shows inconsistencies in the object's expected water-ice signatures, even though it looks comet-like as it approaches the Sun. Unlike typical comets that develop prominent tails and comas as solar heating sublimates their icy surfaces, 3I-ATLAS displays minimal outgassing activity that seems, honestly, artificially suppressed. The object's brightness variations follow patterns that suggest either an extremely unusual internal structure or, maybe potentially artificial modifications to its surface properties. Dr. Michelle Bannister from the University of Canterbury notes that the thermal signatures just don't match any known class of natural celestial bodies, creating a scientific puzzle that's got researchers scrambling for explanations. Ground-based observations using the Keck Observatory have detected anomalous reflectivity patterns across different wavelengths, suggesting surface materials or structures that shouldn't exist on a primordial comet from interstellar space. These mysterious characteristics are forcing scientists to consider possibilities they previously dismissed as purely theoretical, opening up discussions about the true nature of our enigmatic cosmic visitor and whether it represents humanity's first encounter with something genuinely extraordinary. The scientific debate. The scientific community has become deeply divided over 3I-ATLAS, with heated debates emerging between researchers who maintain it's a natural comet and those who suspect something far more extraordinary. Dr. Robert Warwick, who discovered the first interstellar visitor Oumuamua, argues that 3I-ATLAS exhibits typical cometary behavior, consistent with objects ejected from distant planetary systems during their formation phases. However, a growing faction of astronomers led by prominent researchers is challenging this conventional interpretation based on mounting observational anomalies. Dr. Matthew Knight from the University of Maryland emphasizes that while unusual properties don't automatically indicate artificial origins, they do warrant serious investigation rather than dismissal. The debate has become particularly intense regarding the object's thermal behavior, orbital characteristics, and structural properties that seem to contradict standard models of interstellar comet evolution. Traditional planetary scientists argue that exotic conditions in other star systems could naturally produce such anomalous objects, while skeptics point to the accumulating statistical improbabilities surrounding 3I-ATLAS's trajectory and timing. This scientific schism reflects broader tensions within astronomy about how to approach potentially paradigm-shifting discoveries without abandoning rigorous scientific methodology. The controversy has prompted unprecedented international collaboration as researchers desperately attempt to resolve fundamental questions about this cosmic visitor before it disappears forever into the depths of interstellar space. The artificial origin hypothesis. Harvard astrophysicist Dr. Avi Loeb has emerged as the most prominent advocate for considering artificial origins for 3I-ATLAS, drawing on his controversial analysis of Oumuamua to argue for serious investigation of extraterrestrial technology hypotheses. Loeb's Galileo project, established specifically to search for evidence of alien artifacts, has allocated significant resources to studying 3I-ATLAS, using advanced observational techniques and artificial intelligence analysis systems. His team argues that the object's unusual properties, including its suspicious orbital alignment, minimal outgassing despite solar proximity, and anomalous structural characteristics, collectively suggest possible artificial construction or modification. Loeb emphasizes that dismissing extraordinary possibilities without thorough investigation represents scientific prejudice rather than rigorous methodology, particularly given the unprecedented nature of interstellar visitors. His hypothesis proposes that 3I-ATLAS could represent a reconnaissance probe or derelict spacecraft from an extraterrestrial civilization, deliberately designed to appear comet-like while conducting systematic observations of our solar system. Critics argue that Loeb's theories lack sufficient observational evidence and rely too heavily on speculation rather than proven scientific principles. However, his work has sparked crucial discussions about how the scientific community should respond to potentially revolutionary discoveries that challenge fundamental assumptions about our place in the universe. The debate continues to influence funding priorities and observational strategies for studying this and future interstellar visitors. Unusual detection pattern. The discovery timeline of 3I/ATLAS reveals some deeply troubling patterns that, honestly, suggest the object may have been deliberately avoiding detection during its approach to our solar system. Even though it entered our solar system in early 2024, the object wasn't discovered until June of the following year, 2025. That means it spent over a year traveling through space without triggering any of our advanced detection networks. Dr. Catalina Oiza from the European Space Agency points out that, objects of this size should have been detected much earlier by automated survey systems like ATLAS and Linear. This really raises questions about how it managed to remain hidden for so long. The object's approach vector from the galactic south actually placed it in a region of the sky that receives less intensive monitoring, which might explain the delayed detection but also suggests, perhaps, some knowledge of our observational blind spots. What's even more concerning is that there's evidence 3I/ATLAS may have altered its trajectory slightly during its undetected approach, and this is based on retroactive analysis of archival telescope data that initially dismissed some faint signals as imaging artifacts. Dr. John Tonry, who leads the ATLAS detection system at the University of Hawaii, admits that the object's discovery pattern represents a significant failure in current detection protocols. This delayed recognition has cost us precious observation time and honestly, raises some uncomfortable questions about whether other undetected visitors have passed through our solar system unnoticed, potentially conducting systematic surveillance of Earth and, human civilization. Suspicious orbital characteristics. Statistical analysis of 3I/ATLAS's orbital trajectory reveals probability patterns so, improbable that they're forcing astronomers to question whether its path through our solar system could possibly be natural. The object's alignment with the ecliptic plane, the flat disk containing most planetary orbits, shows a deviation of less than 0.2 degrees, which is a precision that occurs in fewer than 0.2% of random interstellar trajectories according to orbital dynamics models. Even more remarkable are the calculated close encounters with multiple planets during its passage, including near-miss approaches to Venus, Mars, and Jupiter. Altogether, these encounters represent probability odds of about 0.005% for a natural occurrence. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory describes these orbital characteristics as, quote, statistically suspicious, and says they're worthy of detailed investigation rather than just casual dismissal. The trajectory analysis also shows that 3I/ATLAS will achieve optimal positioning for observing Earth's electromagnetic signatures, like our radio communications and radar emissions during its closest approach phase. Now, some skeptical scientists argue that unusual orbital alignments do occasionally happen in nature and don't automatically indicate artificial guidance systems. But the cumulative probability of all these observed characteristics really challenges conventional explanations. Computer simulations run by planetary dynamicists show that achieving such precise orbital parameters would require either some extraordinary cosmic coincidences or maybe deliberate course corrections throughout the object's journey. These findings have sparked some serious discussions about whether 3I/ATLAS might actually represent evidence of intelligent navigation instead of just natural gravitational influences during its passage through our solar system. The hidden approach strategy. Perhaps the most disturbing aspect of 3I/ATLAS's trajectory is its perihelion timing, which, honestly, creates a strategic blind spot for Earth-based observations during the most critical phases of its passage through the solar system. The object's closest approach to the Sun happens when Earth is positioned on the opposite side of our star, which severely limits our ability to observe it during the period when thermal effects should be most pronounced. Statistical analysis shows that only about 7% of random interstellar trajectories would produce such observationally challenging timing, suggesting either an extraordinary coincidence or maybe deliberate planning to minimize detection and study opportunities. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies points out that this timing pattern would actually be ideal for a reconnaissance mission trying to study our solar system while avoiding detailed scrutiny from Earth-based instruments. This positioning allows 3I-ATLAS to conduct close-range observations of multiple planets, including Earth, while staying mostly hidden behind the Sun during its most active phases. What's even more concerning is that evidence suggests the object's brightness variations follow patterns that hint at controlled orientation changes, potentially optimizing its observational capabilities while minimizing its visibility signature. Critics, of course, argue that this interpretation leans too heavily on circumstantial evidence and ignores natural explanations. But, the accumulating patterns are becoming pretty difficult to dismiss as just pure coincidence. Scientific opposition and evidence. So, the mainstream astronomical community, they've mounted some pretty strong opposition to these artificial origin theories. Their main point is that, well, extraordinary claims require extraordinary evidence, and honestly that kind of evidence just hasn't been provided for 3I-ATLAS. The Space Science Institute, for example, emphasizes that, while unusual orbital characteristics and timing coincidences are definitely intriguing, they don't really constitute proof of intelligent design or extraterrestrial technology. Leading cometary scientists also point out that interstellar objects naturally show properties that are, pretty different from solar system natives, and that's mostly because of their exotic formation environments and exposure to harsh interstellar conditions over millions of years. Now, when it comes to size estimates for 3I-ATLAS, things get even trickier. The numbers are, well, highly uncertain, ranging anywhere from 5 to 20 kilometers, and that depends a lot on assumptions about surface reflectivity and composition, so making a definitive characterization is, honestly, extremely difficult. Dr. Quanzi Ye from the University of Maryland, for instance, argues that the object's minimal outgassing could actually result from surface processing during its interstellar journey, rather than from any kind of artificial suppression of natural comet activity. Spectroscopic observations have detected conventional water ice and carbon-based compounds, which are totally consistent with natural comet composition. Still, proponents of artificial origin theories point out that camouflaging technology could, in theory, easily incorporate such materials. All in all, the scientific debate here really reflects some fundamental philosophical differences about the burden of proof and, what the appropriate response should be when we come across anomalous observations that challenge our established paradigms. Ancient origins and anomalous behavior. Age determination studies suggest that 3I-ATLAS may be over 7 billion years old, making it significantly older than our solar system and, well, raising some big questions about its formation environment and subsequent history. This extreme age implies the object formed during the early phases of galactic evolution, when stellar metallicity and planetary formation processes were dramatically different from what we see today. Despite its comet-like classification, 3I-ATLAS displays virtually no visible tail or coma development, even during close solar approaches, which really contradicts some fundamental principles of cometary physics and sublimation processes. Dr. Colin Snodgrass points out that the object's thermal infrared signature just doesn't match standard models for water-ice sublimation, suggesting either an unusual composition or maybe even artificial thermal regulation. Structural analysis, meanwhile, indicates internal density variations that seem inconsistent with natural accretion processes, potentially implying deliberate construction or modification over geological timescales. The water-ice spectrum also shows anomalous absorption lines that don't perfectly match laboratory standards, hinting at either exotic crystalline structures or contamination with unknown materials. And if that wasn't enough, there are periodic brightness fluctuations that occur independently of the object's rotation, which suggests internal activity or controlled surface changes, rather than just simple light reflection from a tumbling asteroid. Taken together, these ancient origins and anomalous behavior patterns create a compelling case for detailed investigation instead of premature dismissal. since 3I-ATLAS may represent our first opportunity to study technology or materials from civilizations that evolved billions of years before Earth even formed. The stealth hypothesis. The concept of deliberate concealment adds, honestly, a chilling dimension to the 3I-ATLAS analysis, suggesting the object may be operating under dark forest theory principles, where advanced civilizations actively avoid detection by potentially hostile neighbors. This hypothesis proposes that 3I-ATLAS represents sophisticated camouflage technology designed to appear as a natural comet, while actually conducting systematic reconnaissance of our solar system and Earth's technological capabilities. Dr. Seth Shostak from the SETI Institute acknowledges that, while this idea is speculative, stealth hypothesis explanations account for otherwise inexplicable observational patterns, better than conventional astronomical models. The perfect timing of its approach, strategic positioning during key observation windows, and minimal electromagnetic signature could all indicate advanced concealment protocols developed by civilizations with millions of years of technological evolution. If confirmed, these stealth capabilities would suggest that 3I-ATLAS represents technology far beyond anything humans currently understand, potentially indicating that extraterrestrial surveillance of Earth has been ongoing for extended periods without our detection. The implications here extend well beyond simple scientific curiosity to fundamental questions about human security and our readiness for contact with advanced civilizations that may be studying us from the shadows. Now, critics argue that stealth hypothesis thinking promotes paranoid speculation rather than rigorous scientific analysis, but proponents note that dismissing possibilities just because they're unsettling is more emotional than logical reasoning. The debate continues to influence both scientific methodology and public policy discussions about how humanity should prepare for potential contact with extraterrestrial intelligence operating within our cosmic neighborhood. Lessons from Oumuamua. The scientific community's response to 3I-ATLAS has been, in many ways, heavily influenced by the controversial handling of Oumuamua back in 2017, when humanity's first confirmed interstellar visitor was dismissed as merely unusual instead of potentially extraordinary. Dr. Avi Loeb argues that the astronomical establishment's rejection of artificial origin possibilities for Oumuamua represents a missed opportunity that really shouldn't be repeated with 3I-ATLAS. The earlier visitor's anomalous acceleration, extreme elongation and lack of outgassing were explained away through increasingly complex natural theories, rather than seriously investigating simpler artificial explanations. Today, our detection capabilities and analytical techniques are way more advanced than during Oumuamua's brief passage, providing unprecedented opportunities for detailed characterization of 3I-ATLAS before it disappears into interstellar space. The James Webb Space Telescope, advanced spectrometry and artificial intelligence analysis systems now offer tools that were unavailable or underdeveloped during our first interstellar visitor encounter. The lesson from Oumuamua is clear. It's important to investigate all possibilities, including extraordinary ones, rather than defaulting to conventional explanations that may not adequately address observed anomalies. 3I-ATLAS represents potentially humanity's second and possibly final chance to properly study an interstellar visitor during this generation, making thorough investigation crucial, no matter the initial skepticism. Scientists worldwide are coordinating unprecedented observational campaigns to ensure that this opportunity isn't wasted through premature conclusions or insufficient data collection. The stakes honestly couldn't be higher, since 3I-ATLAS may be our last chance for decades to determine whether we're alone in the universe or sharing it with advanced civilizations. The mystery of 3I-ATLAS continues to deepen with each new observation, challenging our understanding of what's possible in the cosmos. Whether it's an ancient comet with unusual properties or, something far more extraordinary remains hotly debated among scientists worldwide. What do you think about these strange findings? Could we be witnessing our first confirmed encounter with extraterrestrial technology? Share your thoughts in the comments below, and don't forget to subscribe to Sci and Y, and hit the notification bell for more mind-bending space mysteries. Keep questioning the universe.